I think I promised to do a little bit of a talk on my most recent paper, which I actually wrote just for this, just to have something to talk about, and because it's kind of interesting. So I'll just show you guys that.
Okay.
And then, so it's 3 flavors, neutrino oscillation, and a Higgs vacuum expectation value. So yeah, so this Higgs expectation harmonic is an idea that I played around with in a different paper, actually, and is the subject of another presentation that I did. Rajan, you'll remember this. It was like the first.
Yeah, some of it, yes.
So it's a simple enough concept that, and I think actually some of the numbers in this are a little bit wrong, but well, they're fixed in the new one anyway. And I have no idea how it. Oh, actually, I do kind of see how it came about. But essentially, it's this part. So the vacuum expectation harmonic. So it's a bit of a strange concept, and I don't have a huge amount of proof of its existence or anything. It's fairly theoretical. But then you have like, you know, the way you have like the expectation value. So the vacuum expectation value, it sounds very statistical, as if it's part of some sort of binomial or distribution, like a standard distribution or something. But obviously it isn't that, because the quantum statistics usually has like, what is it, the mod squared? So it's like the complex conjugate squared value, which is kind of the opposite to variance, which you were talking about before, variance and standard deviation, because standard deviation is the square root. So
yeah,
but usually the vacuum expectation value is 246.22 GeV. So I had it worked out that if this point up here is the Higgs boson, and this is 246.22, which is the ground state expectation value, and that comes from this little equation, but there's also many others. That's kind of my version of it. Then, you know, so this is your Mexican hat, like we were talking about, and goes up again. So it could like continue to just go up and down in a radial fashion. So if there's a Higgs here, there could be another one here, another expectation value here, another Higgs here, another vacuum expectation value here, and another Higgs there. So given that, it's easy enough to figure out the different values for the. So that's the idea of a harmonic, because they're like, you know, like the way waves are in harmony with each other. So you'd have like the first vacuum expectation value at that range. Then the next one is just, you know, so it's bigger again. So it's like 3 times the size, and then 5 times the size. So it's always some odd valued multiplication, because you have it here 5 times the expectation value, you know, and this helps you get the masses of the particles, or 3 times the expectation value gives you the mass of the bottom quark. With other stuff involved in there as well, like the mass of the Z boson and the mass of the tau lepton. So, but what was the point I was trying to make there? So there's definitely like a harmonic thing. So you'd go, there's the first Higgs, then you have vacuum expectation value, then second Higgs, and then third. So 1, 2, 3, 4, 5. See what I mean? So kind of like, so that's the basic idea on that.
So with I have one question. The vacuum expectation value, is it anyway connected with 0-point energy?
I think so, because if we look, I think I've even repeated it in the new. I think like from the perspective of maybe conventional physics, or should I? Conventional physics is the wrong word, but you know, the consensus maybe.
Okay.
Although there's probably not huge consensus all around these issues, but I'm not sure like if there would be a big connection drawn between the vacuum expectation value and 0-point energy. But I think that it's looking like there could be a relationship.
So Christopher, are you also trying to do like a vacuum catastrophe you will be able to resolve with this one? Do you have any idea about,
no, I have
possibility?
Not. I haven't been looking into that at all, but there is something that's kind of dovetails with your work that you presented last week. And it's this subject here about you have a 4x4 matrix with the gradient and the rotation value, and then all of them go to 0, I think, except for one, or one is the mass, and it shows that even in a vacuum there's something there. So, and this is the exact same condition here, where we have the 4 different components of the Higgs field prior to its collapse into the standard Higgs field.
Can't hear now.
Can you hear me?
Now I can hear.
Okay, good. So these are the 4 different components of the Higgs field. And this is prior to the collapse. So 3 of them get absorbed into the electromagnetic spectrum, and the other one is left behind. So here they are here, 1, 2, 3, 4, and 3 of them get absorbed, and it just leaves 1 behind. And that 1 is then the vacuum expectation value. So I think that's yes, because you were asking, is it related to 0-point energy? Obviously, something that's left behind in a vacuum, well, it could be, I think you were suggesting it might be dark energy or dark matter, but definitely something like vacuum energy left behind. Okay, so there was another question I think you had there. I might be able to get to it later. Keep it in mind. So basically, I've done what this is really about is about the 3 flavors of matter. So you have 3 different generations of matter, or for all fermionic matter. So like the electron, muon, tau, and then the neutrino versions of those, and not to mention the 3 different flavors of quark. So I've kind of looked at this problem from a number of different angles, from full octahedral group, a purely geometric explanation, and then using quaternions as well. So I just the full octahedral group one is based off the Dinkin diagram, which is a pretty important subgroup. And there's some of the subgroups there. And this kind of leaves you with a structure where it goes electron, mu, tau, electron, neutrino, muon, neutrino, and tau neutrino. So they're kind of stacked. You need to like rotate this by 90 degrees before they become in line, you know, because if you take this as 3 generations, it has to be vertically. We're talking about 3 generations vertically. So you kind of have to rotate those. And a similar situation occurs in another paper I wrote, where it's called Revisiting Triality, where you use what are those quaternions again? And basically it shows that when you use the quaternions in the right sort of way, using SL23 and GL23, you wind up with this kind of thing. So, or like these are all the gravitons and the gluons together, and you can do it with GL22 as well. But skipping over that, just getting to this. So you see like all the heaviest fermions are on one table, then the next heaviest are on another table, and finally the lightest are all on their own table. And that all comes again from the GL23 stuff. So I mean, that could be reworked. I mean, that might not be totally right, but it could be right from one perspective though. because there are this kind of stuff is being reworked all the time, so I have to, okay, it's being rejigged. So there's like three. It seems to be that just like the way this is on 3 different levels, the bigger tables are also on different levels. So all of the heavier fermions are collected together, then the middle ones are collected together in their sphere, and so on. It's not like it might be depicted here, if you will, in a vertical sense. That like it's just all of the charged fermions together and all of the weak interacting fermions together, or they're not grouped in that sense. This was the geometric version, which we won't go into, but it's basically that there are 3 stellations of a rhombi dodecahedron. So yeah, it could have something to do with it in terms of the field, but it has the least to do with this current work, so I kind of skip over it. So there's that equation again that I used to generate the Higgs potential. This probably would be a better version because it shows it petering out after like 3 or 4 waves, which would be important if we're saying that this is only got a vacuum expectation, like there's only 4 Higgs particles in the 288 cell standard model. So 1 Higgs, 2, 3, 4, and then nothing after that. So it has to kind of peter out. You can't just keep going indefinitely, unless it repeats indefinitely, But I don't know about that. So here we go. It's kind of a bit more streamlined in this instance. We have exactly 3 expectation values, which means that they are the intervals between the 4 Higgs particles. So we can see them here. Higgs 1, this is the one with the mass, 126. These are all massless because they lie on just as the Goldstone boson rolls around at the bottom of these expectation values and has no mass because it rotates in a circle. Actually, it's a 4-dimensional sphere, but because this whole thing is 5-dimensional. The 3 new speculative Higgs bosons will kind of very delicately, or they might even be this entire ring here, just as this is a point, they might be this ring. So just as the Goldstone boson goes around in a circle, so do the other 3 Higgs particles. So they are also massless according to this theory. So like I said, you have the 4 Higgs acting as like interval boundaries between the 3 groups of 8, 3 generations, each with 8 fermions in them. So plus their antimatter counterparts. So the idea is like, let's say you start with an electron. Somehow it has to breach through the potential well here to become a muon, and then a tau, and back again. And the same thing has to happen with the neutrinos, and assuming with these guys as well. So some like possible explanations for this could be like quantum tunneling, where it kind of just jumps through, but that seems unlikely. So I was trying to think of like a new kind of geometric structure. Maybe there's like holes in there's gaps or something where they can fall through. But so what I settled on was that, a kind of a spiral shape. So this is the inner kind of zone, and then they're able to move out and out. And when they get out to the third one, they, with each step outwards, they become heavier, and so therefore a different potential.
I have a question.
Sure, go ahead.
Okay. I don't know what. Let me check why there is so much of echo or something.
Oh, you can hear echo on your side, can you?
Yeah, now it's okay. Oh, okay.
That's weird and concerning, Rajan.
Yeah, it was coming on for a while now. I don't know.
Oh
In any
no.
case, I think I'll switch off and come back. But one question, and then after that I'll switch off. Come back again.
I don't think it might be my computer actually.
Oh, really?
Yeah, because maybe like if I talk like this, is it back? Hello? Can you hear now?
Oh, yeah, it's still there.
All right, so it's really, I think it's just me. If I'm too close to the computer, then
okay.
I'll have
Anyway,
to
we'll try this switching off and all. But the question is, will it act like a maze? You know what I mean?
Yeah, I do know what you mean. I think, yeah, if this is considered a maze, then yeah, probably. But I mean, it's a pretty rudimentary maze, I guess.
But you can connect to magic squares. That's what I'm trying to think. If it is a maze, it's easier to connect to.
Yeah, well, I don't know actually, because magic squares and mazes, are they very?
It may be coming together. Anyway, I'll switch off and come back. Let me try also.
I think you're okay, Rajan. I wouldn't bother. I think it's just because I was too close to the computer. Okay, I mean,
better now?
yeah,
better.
Yeah, I think it is probably a lot.
Little better.
Cool.
Okay, that's good.
A little bit better is better than the thing.
So what I was thinking is that today I was like a couple of days I was thinking about a prime square. It has, remember algebra that even John was talking earlier. So I was thinking about algebra in general. What is it solving? So what all things is, suppose you have number of particles, right? Particles arranged in certain way. You have n number of particles. Now, you know that arithmetic progression, right? It's a nice formula I learned when I was in high school, middle school, high school. You reverse that and then add them together and you get nice algebraic formula, n times n plus 1 over 2. So you can calculate for any number. You don't have to keep adding. So arithmetic converted to algebra. And I was thinking, same thing can happen with a particle and an antiparticle. If we flip them around and add them together, they'll all add, and then we can find if there's n number of them, you can find out what it will be. Okay. Now, it may not be that simple because when I look at the sum, they are not arithmetic progression. It may be more like magic square progression. So then it's a little bit complicated, but you can use that same concept. And what it will help us is that that particular set of particles are formed, for example, by prime number factorization. Okay, and then when they add them together, they form. When you add them together in the algebra, the magic square comes into picture automatically. So
okay,
I think
maybe don't do it next week, obviously, because we're not going to be here. But the
following week.
Yeah, if you could, because like it sounds interesting, but without some sort of visual guide or the maths,
yeah,
it's very difficult to follow that. But I do, I like the sound of it.
Go ahead.
This idea of like three generations. Oh yes. Yeah, so if you look here, like the title of the paper mentions neutrino oscillation, and I get as far as the spiral part, and then it goes into references.
Okay.
So the title includes something that the paper doesn't. I completely forgot to add in neutrino oscillation, so that's gonna be the next step. I'm gonna just add that in.
Okay.
Later. I mean, and anyway, the situation is a bit more complicated with neutrino oscillation than I had initially sort of conceived of. You can see here after 1 kilometer, you still have mostly neutrino electrons, but gradually some of the neutrino muons and taus are creeping in. And you can see how complex the situation is. Like after 10 kilometers and what's this, 80, no, 60 or close to 70. So, and that's only one sort of graphical description of it. There's actually many others. So this might even be more accurate. So it's clear that this is a pretty strange series.
Oh, yeah.
Wager. So the idea is like, because we're dealing with a 5-dimensional wave function, which is what the Higgs field is for sure, mathematically, and because we're essentially, how would you say, transforming it into a spiral. So like, what is the geometry of a 5-dimensional spiral? You know, I've never thought about that before. I haven't even really thought about a 4-dimensional spiral. But if we look at this, like, are these waveforms, could they be generated by the interaction of these particles with a 5-dimensional structure like this? Do you know? Or could and I think there's a good chance that it could be, but that's one good thing about this theory is that it's definitely falsifiable, because if you cannot recreate this using a 5-dimensional spiral system, or even, you know, well, even, yes, but let's say 5-dimensional, then that concept is definitely wrong and provably wrong, which is a good thing. So,
oh yeah.
Also, then, like, we can just look at crazy spirals doing what they do. I hope you can just look at these. This isn't copyrighted, but if it is, you can see the source is right there. And this looks like a kind of a sciencey paper anyway. I haven't really had time to read it, but it's trippy looking.
It looks like one of the, you know, oh, Wansang is here. Okay, welcome, Wansang. So, yeah. See, they have this
Landau equation. Ginsburg, Landau. Landau is, he's not the guy who worked with, what's that stuff Alexei works with? The, you know, the really cold, super cool, maybe I'm thinking of someone else. I am actually, but maybe not. Superconducting fluids, superfluids. So if I go back here, so any theory with crazy spirals like this in it, any physical theory is pretty good. It's kind of onto a winner, I think, you know. It's always nice to have some sort of geometry that can be utilized.
Dynamics, it shows the dynamics.
Yeah. So, I mean, there's this crazy website as well with.
You created all this stuff?
No, I didn't know. Actually, that's a good point. So I don't know. Again, like, all credit to this blog, Aki GIFs, but I don't know who created this. But you can see, like, there's here it's like things are expanding outwards, yeah.
Oh yeah.
Whereas here it's like contracting inwards, and this kind of goes to your other point that you were making earlier, which I kind of said, you know, keep it in the back of your mind. But if we go down here where you were talking about vacuum, 0-point energy and the vacuum. If we look at this one, you'll see that there's no difference between just a rotating spiral and an inflowing spiral, you know, geometrically or visually.
Could be vortices, right? Is it like vortex it's going?
Yeah, exactly. So it's very much following into your work and possibly even John's and
even.
Of course,
the friction may be happening. The friction may be happening in that vacuum.
Well, you have like the whole thing of sinks and sources and sinks. Now, I wouldn't be making a strong connection between my work and their work because it's so different.
Yeah.
But
I mean, there's a lot of things to be.
Sorry, wait, I have noticed that your work, Wenzong's and John's, are all very they're becoming quite aligned, you know, in terms of vortices and sinks, and it's interesting. Sorry, what were you going to say, Rajan? Do you remember?
Oh, let me see. One of the things I was thinking about that prime factorization, but along the line,
Well,
there
just
was.
go ahead. There was this thing here that I wanted to talk about.
Oh, I was talking. Okay, go ahead.
Yeah. So this is rotating and going inwards at the same time. So if we were thinking that instead of having the particles rotating outwards, maybe the field is rotating, and therefore the particles are kind of staying where they are and are just moving out. That might not work though from an oscillation point of view. But I just thought it was interesting, when you talk about space expanding or contracting, it could like the way this looks like it's contracting, but it's not really contracting.
Yeah,
So anyway, that was just like a half-formed idea I had when I was kind of flicking through these images. But could a five-dimensional, just thinking about it now, could a five-dimensional waveform contract and expand in such a way as to generate these kind of patterns? I don't actually have the answer to that. That's just an open question. So I think you froze there. Yeah.
When the waves start to converge together, they can eventually form a particle. I think the particle, in the ultimate sense, is a condensed wave. That's my feeling. When the wave starts going inwards and starts rotation field and start converging, it eventually forms a particle. So there is a direct connection. So what happens is a symmetric. The wave and particle has some kind of symmetric aspect. Like particle going in, the wave comes out, and the wave comes out, particle goes in, something like that. So it tries to be symmetric or anti-symmetric to each other. It's a possibility. I'm not sure, but
no, it just sounds very. It sounds convincing. It sounds like a solid idea. I mean, you have like this idea of obviously the massive Higgs boson is sitting at the center of that waveform, which is either moving in or going out. So like I said, that was just an idea I had while I was researching sort of spiral images. And kind of giving myself a proper headache at the same time. So I definitely lay off the spiral images for the rest of the evening. So that was kind
you can think of like pieces of puzzle you are arranging, like pieces of puzzle, and then they come together somehow, fall into piece, and you get a solution. Sorry to be interrupting you, but
no, it's grand. A very interesting point, I thought, Rajan. There was just like, when I had something in mind and I knew it was like only like a very small little, when you have something little left over that you just need to kind of, if I left it too long, it would be gone. So I needed to make sure I finished, and that was it. So that was just like a little bit of a presentation there, because I know you did a presentation last week, and John obviously has done too. So in the last 2 weeks, nearly. Yes, there we go.
So this is the conference. The accepted papers, accepted. It's the 17th and 18th.
There, yeah, great.
Mine is the very first. So they have put it, but somehow, I just sent it yesterday. So they have not put that, but somehow one of them they have put, but most of them they have not put. Like this one, these people might have sent it earlier. So it will appear like that. It will appear like that. But I'm saying it will appear like that. So in this one, the acknowledgement, I have your name on all. They have not put acknowledgement, but in my paper. So maybe they will load it tomorrow or day after, because 17th and 18th are the thing. And they asked me when I can present it. So we are talking about it. They actually want me to present live possible, but I don't know, the times are clashing because this is in Iran. So day is night there. It's about 9-10 hours ahead from here. So they're trying to find out. Maybe I had to present. I may be one of the first presenters. I don't know. So I'm trying to see. And I told them that you have made, initially we made, it was like 45 minutes of, talk and then half an hour of Q&A, but we shortened it.
Half an hour, Rajan. I think there was an hour Q&A or something. Go on.
Yeah. But at least half an hour,
Oh, yeah.
So I said that we are putting in YouTube. I said that you are organizing also TechNet, the text things, videos, YouTube. So they are kind of aware of it. So they will, I think, go through it and see. And they want to make a movie. So I don't know. I asked them what exactly they mean by that.
And what did they get back?
I asked clarification. So I think they have, yeah. So I said that,
Rajan,
whatever is there. Yeah,
Rajan,
go ahead, please. Go ahead. Thank you.
Did they get back to you about about the movie? Did you ask them what for clarification? Did they ever get back to you?
Yeah, they actually sent me. What I said was I sent the slides separately because in this video only 2 slides are showing. Only the first and second shows, because when you shorten that, it shows only the 2. But there are 8 slides in there.
You literally only had 2 slides.
Yeah, but the whole
slide,
thing.
And then you had an abstract slide which you skipped over, and then you went straight to the second slide. And I thought, like, thinking back on it, I was like, oh yeah, there's 3 slides. Like, I thought you had another slide after that. But you didn't. You had 1 slide.
Yeah, because see, I didn't realize it was 15 minutes. See, they send me later on. It's kind of a rush thing. They already accepted like November 5th or something. So I was not sure whether I will be in there or not. So November 5th, after November, immediately they sent out.
I don't understand that. They only accept number what?
They accepted only the November 5th of November.
So 5 people or what?
No. I'm saying that the closing date was 31st of November. Yeah, no, November.
Rajan.
Yeah, so it was a kind of a rush thing. I didn't know whether I will be in there. And
well, it looks like they've accepted your paper, man.
Yeah.
Accepted your paper, so.
Yeah. So they put me as first also. So we will see how things work. But they know that times are clashing, so I may not be able to be present. I'm not sure, or I could be present, depending on the time.
Right. So that's very good. And so this is a conference in Iran, which is pretty cool.
Yeah.
You were talking about having different conferences. One in Hawaii, 2024.
Hawaii, 2022, 2023, depending on how the COVID and other things that we all come together.
2022 is just next year.
Yeah. We hope that Vincent, John, all of us, for sure, Manuel will be the main people, but maybe be other possible honorary speakers, top level speakers, either for Hawaii or later on. The Hawaii conference is set up for World University. That will be like 2024. So Manuel is also interested in that.
So what I'm getting back on point here. So I'm just wondering, right? So you're talking about the kind of what would you call them? The logistic challenges behind doing a conference in Hawaii, and obviously aside from like the money, that it costs a good bit to fly there, and all the rest. There's aside from the money aspect, which is actually a huge aspect, but aside from that, like everything else is very reasonable. You've 20 people, you've got a place set up already, and it'll be a sightseeing thing, which is obviously very important if you're in Hawaii. There's the volcanoes, they're very topical at the moment as well. So all of that, but I'm just saying, then transport that to like the Arctic,
Yeah, good point. You brought that. Thank you. That's why you should be at the helm, because you should be guiding people and then stopping them. Eventually, you will have that power. Once the chancellor and everything, you will be the official people. You know what I mean? You and Emmanuel will be official people, and we'll be just advisors and things like that. So you will guide, and you can even have. I'm thinking later on, like a mic, you can switch it off, switch it on, like that. Okay, if they're talking, you can switch it off. All this.
Technically, I have the power to do that here, but I don't. I give people free rein to speak. But the thing is, I'm not like against the idea of
No.
I think it's a really cool idea. I'm just, so like you could do something like, I mean, I think in terms of price, it'd probably be a good bit higher though. So, but it's still a great idea. Actually, recently, it's kind of it's relevant to what we're talking about, but I don't know how relevant it is in general to real life. But recently on YouTube, I've been recommended a lot of videos of people, so scientists and researchers in the Antarctic, and they're always in these condition 1 storms. So they're in their science buildings, but they like open the door to the outside, and there's just this like intensely like howling gale going on outside, and it's pitch black and loads of snow. So I thought that was really cool. Obviously, there's there'd be an element of that if you're to plan on having a conference in the north. But I mean, again, like if you're interested in traveling, and of course, some of the top places to see would be Hawaii with the volcanoes, the Arctic, North Pole, ice, tundra, all of that. So I mean, obviously, it's a great idea if you're going to have global conferences to put them in interesting places. So I think it's really cool. I mean, you could technically have one in my country, Ireland.
Oh yeah.
We could have one in Siberia, closer to Alexei.
Yeah.
That'd be great. I mean,
every year, we can do every year like that. Each year will be a different place.
Yeah, like you guys to
It will be yearly thing. Other times we are going to do this online, 2 weeks, every 2 weeks.
See, the great thing about online is it's the cost, because I don't think like unless you're talking about maybe funding, but like the majority of, if we were to get funding, like the vast majority of the funding would have to go on actual projects and research.
Oh yeah.
Shouldn't be spent on like
no. It will be a certain percentage. That's how we do that. The idea of World University also is understanding about global warming and what we do. It's a real problem because when I see this, many of the ice have melted, and also the rivers are overflowing, and the temperatures risen, and we have water shortage now here. So there is a real inversion. Yeah. How is it there in Ireland? You have that problem?
They say we have a water shortage. Like if there's if the summer is hot, like for like a couple of weeks, they go, all the reservoirs low and don't use hose. But I mean, I don't know. Like we always have water here. It's a rainy.
We also have. Yeah. There's no problem right now, but they think that next year onwards they'll start cutting down. But so global warming, that was a big thing for me. To go to see, I had an idea about metrics graphing, and I think that they couldn't. So far they couldn't prove whether global warming is due to humans or is it a natural process, because natural processes go through these kinds of things. So I had a way to understand that and also replot it and the metrics graphing where it will clearly show if it is a human or things like that. And I was briefly talking to an ornithologist about the guy in Poland, the professor from Poland. And he thinks that's a very good idea because, I mean, he liked the idea because Wegener, Wegener, he talked about how the magnetic poles shift and causes the earthquake and things like that. The continental shift. He talked about
pole shift.
Yeah, Wegener. He was one of the first.
I didn't know.
Wegener.
Hang on a sec. What are you saying?
Wegener. Wegener.
Oh, okay. Yeah, I have heard of the pole shift, and I think Einstein was looking into it as well, was he?
Yeah, many people are looking into it, and 2012, the movie 2012 was talking about it.
Yeah. So are you suggesting that is a thing that could happen in the near future? Or?
Yeah. Because I think there is a time shift. I believe that's why I want to. Our thing eventually will start understanding about time. Like John was saying, the least thing we understand is about time. We still don't understand anything much about. I agree with that.
Very little about time. Yeah.
So I think there's a time shift. So when we see things, the actual things happen after a decade or a century after. And you can see, if you do some statistics, you will see that's very true. It's actually time shifted normally, the events. But we understand them as scientists or something earlier. But we put them away. We don't pay attention to that. But when it comes back, like the people, what do you name? The Da Vinci and the other person. There was another French guy who predicted a lot of these things. Nostradamus, you know. So because these people have visions and scientific visions, and these things happen at a time shift. That's what I find. And I myself, for me, it occurred like in the 80s. Now it's happening. People didn't believe. Are you joking? They were laughing at me. But now it's happening. Myself and Professor Pikani, we were talking about the global warming, other things, and they were laughing. You know, you are joking. You guys are joking. You guys are jokers. So now it's happening. Can't they face it?
But I mean, there are people who call into question like global warming. Like if you went back, I think was it early 2000s, you had the movie with your man, An Inconvenient Truth.
Yeah.
And that was a huge deal. And everyone watched that and we were all like, oh no, the world's gonna end, you know? And then but then there was the ClimateGate email scandal that happened in England in around 2010 or something like that, where they had the hockey stick. So it was like, oh look, temperatures are going to soar, and then they realized, oh, this has all been faked, and all of the people and the emails were like, well, we need to massage the data to make it look like things are trending up and all this. And that was a huge scandal, and everyone was like, okay, so global warming is a hogwash, or they should have been. There was a big noise from the media saying, no, don't listen to that, and then I think the collapse happened, or something happened anyway, and people stopped talking about that, and then the media came back with the really loud message of the science is settled, and if you disagree, you're a whack job or whatever. So I find that a bit really
melodramatic.
There is another issue here which I think which ties into what you're saying, because I'm not disagreeing with you entirely, certainly not when you're talking about a paradigm shift, and I would say that like global warming, or the agenda behind global warming, is certainly involved in a paradigm shift. Like if we look at what do they call it, Agenda 21. Well, the year now is 2021, so it's obviously talking about this year, because the whole world has been totally locked down in preparation for this.
It's got frozen for a minute.
Well, basically what I mentioned Agenda 21 and the year 2021, so they seem to be linked. And then there's the Great Reset, and the fact that we're all kind of, if we went back 10, 20 years, like we would never have been having these kind of video conferences.
Oh yeah.
So we've kind of played into it a bit, like, but if you look at Facebook, recently has decided to completely shut down its operation, and it's starting, or it's changed its name to Metaverse. So the next stage will be kind of a virtual reality conference thing. Like I clicked on a button there a minute ago where by accident, where it put us in a conference room, but it would be like that, but it would be virtual reality, and you could have, like, you look either like a cartoon version of yourself, or you can look like a dragon, or whatever you want to look like. And then there'd obviously like be business, kind of more business meetings like this, but you'd be standing in a room, like, kind of thing. So it seems like the point I'm making is that with the global warming thing, they want to shut down travel. They want to shut down meat production, and they want to like restrict people's freedom of movement a lot, and they want to restrict what you eat, so you'll only eat meat like a couple of times a year maybe, and probably vaccinations quite regularly because of COVID, which is another reason why they don't want you to move around. So it's kind of all like perfectly and then the Great Reset. So they're going to get rid of money, and then all money will be digital. So it's kind of like a kind of an ecological reset of the planet that's also highly technological. And obviously there's a lot of people who are really positively behind this. I mean, especially if you're talking about a kind of a new age movement of like a new paradigm shift into a greener, more technological future. I mean, who doesn't want that? That sounds fantastic. But the reality is that it's probably going to be a hell on earth.
Oh, yeah. That's why I think that the World University also, I mean, we'll lay out more. There's a blueprint I have in the mind, but we have to put that. But eventually there'll be this library, like there'll be auditorium where people just talk their own record, nothing else, just talk. So they get the same page about everything. Then the library type classroom, information room where presentations occur, and then other people will be writing down things. And then there will be blog room like work area, project area, where people now can, like, you have questions, that they will be feedback about that and answer questions, but mostly through like ResearchGate, very similar to ResearchGate, they'll be doing that. And then they'll be meeting. After that, they'll be meeting like we are doing, meeting to find a conference, like honorary speakers, top level speakers talking about it. And then after that, there'll be a launch room.
Rajan, can I ask, because I didn't follow the segue between what I was talking about and what you're talking about. Did you move on to, what did you move on to? Is this about the university?
The North Pole, yeah.
Oh, okay. Jesus, I didn't. So right, this would be like a conference in the North Pole that would be more. Give me the breakdown again.
Yeah. So after Hawaii, we'll be making decisions about this one in Hawaii. That's one of establishing the World University. So what happens is the first one will be the North Pole, and then after that it could be in Ireland, South America. Every year, it will change venue. Different places. It could be Antarctica, it could be Australia, it could be in Siberia,
South Africa, wherever.
Yeah. Every year it will change. The venue will change. So the idea is that eventually, these people I talked to Hawaii, they were in military and everything. They are GIs. So military had to be involved in some way. I'm sure the American military and the NATO and everything has to be involved because, they have to ensure some things. And I come across few people.
Why do they have to be involved?
Because there are logistics involved. So they had to play a background role, to ensure that our things are secure and everything. That's all. I think that
support. About a conference with 20 people in it. Am I not right?
It may not be a big thing, but just to be on the safe side. But the thing is that the idea is that eventually there'll be a launch room after the launch where the SpaceX people, the Amazon people, they'll come together. Hopefully they'll sponsor. And I sent out some feelers to that, and they seem to be a little bit interested in our thing. So Elon Musk may be favorable to that. Amazon, I had the book from Amazon, so Bezos may be favorable. The idea is that you never know what will happen to Earth. So if you have to launch it to Mars or Moon and Mars, that will be ready to go. So there will be a launch site where the science will go into space. Like I was talking with Emmanuel also, these things. So we'll go into space and continue our thing.
That's great. So, well, I mean, if you're into traveling, then space is definitely
galactic.
Yeah. And I mean, like if you'd said this maybe 5-10 years ago, people would laugh at you. But obviously, there is a definite shift going on in terms of technology. I mean, what Musk has done in the last 3 to 4 years, was inconceivable 10 years ago.
Yeah.
Well, like we could conceive of it, but it was like, yeah, right, like that's never going to happen. Maybe in 100 years, maybe 1,000, But now it's like, yeah, they can actually re-land the rockets, and it doesn't even look real, but it is. It's like so real. I mean, it's so good that it doesn't look real. kind of
Space tourism, they already started. Like a few people already gone and come back, like Shatner. I believe in Star Trek. I was a Star Trekkie also when I was a graduate student.
Yeah,
so I like things.
Shatner had been into space.
Yeah.
William,
so he went to about space.
I did not know that. One thing though I will say is about the current state of space tourism. I couldn't care less about it. But I think if Musk his Starship and all of the rest, and he actually starts sending people to different planets, I think it could be really, really impressive, down the line. But there's another physicist, he's a chemist actually, online, who does a lot of videos kind of debunking or questioning some of Musk's projects. And I think there may be just clickbait, kind of, just to get views off people on YouTube, because it's kind of a controversial issue and because he's very good at it. But like, so for instance, the Hyperloop, he's very much down on that. He doesn't think that's going to happen at all. Fine, I'm okay with the Hyperloop not existing. Personally, I think it is a kind of a frightening idea, but it would be very fast. But the other one Musk had was like tunnels underground with cars. They're driving themselves, like no drivers, just automatic, and they're moving really fast. And it's another great idea, but then I think he tried to realize it in Las Vegas, which isn't too far away from you. And I think he's got like underground tunnels, but they're not self-driving. They have real drivers, and they can also only go at like 35 miles an hour. So this guy, Thunderfoot is his name, and he's obviously he's right about this underground system. Musk totally failed on that. In fact, if you were to look at those two projects, the Hyperloop, which is not existent at the moment, but could be in the future, and the self-driving underground cars, those two projects are failures at the moment, But then you compare it to SpaceX, and it's like, SpaceX is like the opposite of a failure, really. It's very impressive. So yeah, I'm just trying to reconcile those contrasts, and I think maybe Musk just needs more time to bring the two things up to speed. What's happening with the AI inside the car? How quickly they're learning the environment. Like there was about 2 or 3 years ago, they were talking about the idea of self-driving cars is now a bust. Like there's no way they're going to learn all the cues necessary to drive in such a difficult environment, and they didn't have depth perception or anything like that. But then within a year, or I think it was less, I think it was within 6 months, the algorithms have actually broken through the depth perception barrier and propelled self-driving, really propelled it, made it a reality again and put it back on track is what I'm trying to say. So that's what I'm saying. So it's like we talk about how things could be slowing down. This could be like Thunderfoot saying, "Oh, it's all fake," or like not fake, but a bit snake oil vaporware kind of thing. But I think the technology is, if it's not here right now, it's kind of building to the point where it'll be here very soon. So it is pretty impressive. Yeah, sorry, I went off on a bit of tangent there, but yeah,
great.
I think space travel could be a definite thing.
Yeah, a definite possibility.
I'm not sure. From my own point of view, I don't see myself necessarily living on Mars, although you never say never. I mean, it could be. I think if you were going to Mars, you'd be dying on Mars, you wouldn't be.
Yeah. If I'm very old, I would probably wouldn't mind,
Yes, that's it. If you knew you had 10 years left to live, yeah.
Why not?